Hello students, today we're looking at 11.6 day 2. We're just continuing on with the quadratic formula. So these first two examples are going to be very similar to what we saw in 11.6 day 1. And we got a couple word problems which I think are really interesting because this quadratic formula is a very real world applicable situation, and it involves physics quite a bit, especially when you get into these real world problems. So we're going to see some things that I think are interesting because they're very real life. So first one here, remember, before we can do anything with the A, the B, the C, or plugging into a formula, we need everything on one side of that equation. We need to be in standard form. So we've got to get that positive 6 over to the left side. The way we do that, introduce the opposite. We're doing that inverse. So what we're going to do is subtract 6 from both sides, so it cancels from the side that we don't want it on. And now we've got on the left where we've got 2x squared minus 7x and then minus 6, and we're all equal to 0. Okay, so once we've got that done, now we're looking at our formula. 2x squared minus 7x minus 6 equals 0. We get our A, our B, and our C. Your A is going to be a positive 2. Your B is going to be a negative 7. Your C is going to be a negative 6. Okay, so now with that formula, we're going to plug those things in where they belong. So x is equal to the opposite of b, which in this case will turn a negative 7 to a positive 7, plus or minus the square root of b squared, so make sure that negative is a part of what we're squaring, minus 4 times a, which is 2, times c, which is negative 6. And then it's all over 2a, which is just going to be 2 times 2. Okay. So now we start simplifying this. Okay, so that negative 7 squared is going to end up being a 49. And then that negative 4 times 2 times negative 6, well, negative 4 times 2 is going to equal negative 8. And then times negative 6 is going to equal a positive 48. So, oops, positive 48. Good. So what we end up with here is you've got 49 with negative 7 squared. You've got 48 with that whole 3 value multiplication. And now when we go ahead and see what that does to our formula, we can rewrite this now. 7 plus or minus the square root of 49 plus 48, because it was a positive 48 that came out of that, all over 4. 2 times 2 is 4. Okay. So now let's simplify what's inside that square root. That's going to equal, so 49 plus 48 is going to equal the square root of 97. So when we take the square root of 97, you are rounding to the nearest hundredth with all these decimal problems. Okay, so we've got the square root of 97 is going to equal, when we round it, 9.85. All right, so where we're at with the formula, x is equal to 7 plus or minus 9.85 all over 4. So remember, this is the scenario now where we have to take one situation where we're adding. So x is equal to 7 plus 9.85 divided by 4. And then a second scenario where we're subtracting. So x would be equal to 7 minus 9.85 divided by 4. So we go ahead, use your calculator to simplify. 7 plus 9.85 is going to be equal to 16.85 divided by 4, rounded to the nearest hundredth, is going to give you 4.21. So your x will equal 4.21. And then your second one, when we subtract 7 minus 9.85 is equal to negative 2.85, divide that by 4, you get x equals negative 0.73. and that's going to be rounded to the nearest hundredth as well. Okay? So I will have, for the sake of keeping this video somewhat short, I will leave that second one be for now. I will finish it before I post the notes, so it will be on the notes, but I do want to get to one of these examples. Okay, so I'm only going to do one of these on the video because, again, I only have 15 minutes as a limit, and I think if I do both of them, I'll probably go over that limit. So for the sake of the video, you're just going to see one of these. On the completed notes, I will have all of these slides done. Okay, so what they're talking about, a model rocket is launched upward with an initial upward velocity of 195 feet per second. So that is taken care of here. They're talking about that right there. That's the velocity, so that's put in there, multiplied by the t for time. The rocket's height h in feet after t seconds is given by the following. So that's this equation that they're talking about. Find all values of t for which the rocket's height is 87 feet. So here's where this is the first time we're seeing something a little bit different. So in a physics situation, you would look at this in terms of maybe a maximum height, or you would be plugging in multiple different height values and see how long it takes to get that height value. Anyway, what you're looking at right now, they're giving you a value of h. You have to plug that in. So we need to plug 87 into that. We're wondering at what number of times, so that there's only one variable here. So what could t possibly be when h is equal to 87? So we're not dealing with 0 right now because they're kind of talking about this situation. We need to make that equation equal to 0. So I'm going to do what we've normally done here. You have to get that 87 to be on the same side as everything else, so we're in standard form. I'm going to subtract 87 from both sides. Okay, so it cancels away from the side that I don't want it on. So I'm going to have 0 is equal to. Now, I'm going to rearrange these numbers so that they're in standard form the way that we're used to looking at them. So this negative 16t squared has to come first. So I've got negative 16t squared. Make sure that the negative comes with because that's the coefficient. This is a positive 195t, so I'll be adding 195t. And then this negative 87 that is being introduced now with our inverse situation from the canceling step that we did, I'll be subtracting 87 from the back. So that's your A, your B, and your C. Once you get those steps done, this is the exact same situation we've been dealing with. Your A is going to be negative 16. Your B is going to be 195. And your C is going to be negative 87. So let's plug this into our formula. I've got x equals the opposite of b, so it'll be negative 195 plus or minus the square root of, so b squared, which is 195 squared, that's going to be a big number, minus 4 times a, which is negative 16, times c, which is negative 87. All over 2 times a, which is negative 16. Okay, so big numbers here, but it's not going to be any different than what we've already seen. You're still going to go through those same steps, and we're going to just simplify this same situation one piece at a time. So the first thing that I'm going to go ahead and do, I like to get everything underneath that square root taken care of. So 195 squared, going to need a calculator for that. 195 squared is going to give me 38,025. So I've got x equals negative 195 plus or minus the square root of 38,025, huge number, minus 4 times negative 16 times negative 87. All over 2 times negative 16, which is negative 32. Okay, so now, one step at a time. Now we're talking about that negative 4 times negative 16 times negative 87. Well, negative 4 times negative 16 is going to be a positive 64. And then 64 times a negative 87, again, we're going to need a calculator there. So 64 times a negative 87 is going to give me negative 5,568. Okay, So now let's look at that formula that we're updating now. I've got x equals negative 195 plus or minus the square root of a big number here, 38,025. And then it was a negative 5,568, so it's minus 5,568. All over that negative 32 on the bottom. And it's about to get cleaned up for us here. We're about to start dealing with smaller numbers, okay? So now I got to take care of what's inside that square root. Okay, so I've got 38,025 minus 5,568. That's going to end up giving me 32,000. So x equals negative 195 plus or minus the square root of 32,457. All over negative 32. So now when we take the square root of it, this is going to suddenly look something like something a lot nicer. Okay, so I go ahead and I take the square root, and the square root of that number is rounded to the nearest hundredth. I'm going to end up with 180.16. Now all of a sudden we're dealing with something a lot more manageable. So now x is equal to negative 195 plus or minus 180.16 all over negative 32. And once again, we're going to be dealing with two situations. One where we're adding, one where we're subtracting. So when we're adding, we're going to have x is equal to negative 195 plus 180.16 divided by 32. And then when we're subtracting, we're dealing with x equals negative 195 minus 180.16 all over negative 32. So let's go ahead and simplify these, and I want to talk real briefly about this situation, kind of visualizing it and seeing what that means. So x equals negative 195. So let's get this on the calculator. So 195, negative 195 plus 180.16. It's going to be negative 14.84 divided by a positive 32. That's going to give me x is equal to negative 0.46 when I round that to the nearest 100. And on the other side of things, I've got negative 195 minus 180.16. That's going to give me negative 375.16. And then divided by negative 32 is going to give me 11.72. And I'm just realizing right now I made a little mistake back here. This should have been divided by negative 32. So that answer should not be negative. And it's talking about time. So obviously we can't have negative time there. So your answers are here. Okay, now let's talk about this way back up at the top in relation to the question. So they're asking for, at what situations is our rocket going to be 87 feet in the air? Well, let's think about this for a second. If we're talking about a rocket, okay, let's say that's like 50 feet in the air, that's 100, that's like 150. Now I don't know how high up this rocket went, but this is going to be the height and this is going to be the time down here. Okay, so your answers, let's just say 2, 4, 6, 8, 10, 12, 14. So that's 2, that's going to be 12. So what this is doing, it's going to create a parabola, right? We're going to launch this rocket up. Now with these numbers, they asked, when is it 87 feet in the air? Right before takeoff, and right after takeoff at about that 11 number. and the parabola goes really high.